Hi everyone, we are here to present Cache and Confuse web cache deception in the wild. I am Syed Ali Mirhedari, also known as Ali, and
I'm Sajjad, also known as JJ, and happy to present our recent research on web cache deception today.
in this research, we are going actually to share a little bit background about the web caches and URL structures. We also want to talk about the path confusion as a root cause of the web cache deception attack, explain web cache deceptions introduced in 2019 by Omar Gil, and we are going to share some new and advanced exploitation techniques, which is very effective and increase the chance of the exploitability by about 45%. And share our notable observation beside the exploitations with bug hunter and audience can invest more times to find more vulnerability based on this observation. Basically, web caches have become an essential component of the internet infrastructure with lots of use cases, such as reducing bandwidth. The study shows that about 74% of the Alexa top 1,000 currently using a CDNs and use a CDN providers and web caches. Most probably others also might use a different cache component and a shitty man-in-the-middle proxy to accelerate accessing to the site. The most common targets of caching are static, but frequently accessed resources. These include static HTML files, scripts and style sheets, images and other media files, or even large document and software downloads.
So since the cache and web caching is an integral part of the nowadays web, the web community come up with some standards and protocols for the different components, such as the CDN proxy and the servers communicate the caching policies. One of the main one is cache control response headers, by which the web server can tell other components in the web how to behave with the response of that resource. For example, the cache control no store tells the response should not be stored. However, the web caching and the web caching components in the internet can ignore these headers and instead use other rules based on the resource paths and the file extensions to cache the resources. So since URL is being used as the main way that the different components communicate to each other, we're going to go quickly over the different components in the URL. So basically the URL has a couple of different components, but the ones that we are focusing on are the path, the query, and the fragment. So basically the path is a file-like structure and separated by a couple of slashes. The query is a list of key values separated by ampersand, and the fragment can be an arbitrary string that used at the end of the URL.
Traditionally, URL reference web resources by directly mapping them to web servers file system structures. As you can see, for example, example.com/account/index.php exactly represent the same web server file system structure, account as a directory and index.php as a file. But also, beside the traditional URL, web servers introduce URL rewriting mechanism, abstraction mechanism to implement advanced application routing structures. There are tons of benefits like as search engine optimizations and others. This abstraction, in other words, web server parse, process, and interpret URL, this second URL, in ways that are not clearly reflected in the externally visible of URL string. In a clean URL syntax, in abstraction syntax, example.com/account/v1, it seems v1 is a file and account is a directory and path. But in the reality, index.php is a file and v1 represent as a value of the parameter one.
So as Ali said, when the web server is using the clean URL, it's completely unknown to the other components in the internet, such as the CDNs and the browsers. For example, as you can see in the account/ID, the browser, CDNs, and proxy think the account is a directory and ID is a file on the server's file system. However, the server knows that the /account actually referencing index.php file in the account directory, and ID is a parameter to index.php, something we call the path confusion. So formally, the path confusion is a semantic disconnect among different framework independent web technologies such as browser, CDN, proxy, server, which technically results in different URL path interpretation. In other words, web servers parse, process, and interpret URLs in a way that are not clearly reflected in the externally visible of the URL string, which could be confusing to others, such as the CDN and the browser and the proxy. So the basic path confusion based on which the initial web cache deception was introduced was actually using the path parameter. For example, if we have the example.com/account.php, the attacker can append the /non-existent.jpg to this URL and request this URL. So what happens here is that to the eyes of the web server, this is a valid URL, and the non-existent.jpg will be passed to the account.php as a parameter. However, the middle components, the CDNs and the proxy, think that the account.php is a directory and the non-existent.jpg is a file. And since the JPG is one of those static content that is usually used by different websites, they're gonna cache the response to that content, which technically results in the content of the account.php response being cached on the server, which could contain some private information.
Yeah, as Sajjad explained, we believe path confusion is a root cause of web cache deception attack introduced by Omar Gil in 2017. And as Sajjad said, in step one, if you look at the pictures, the attacker tricks the victim into visiting a URL that requests account.php/non-existent JPG. At first glance, this appears to reference an image file, but in fact does not point a valid resource on the server. In step two, the request reaches the web server and is processed. The server in this example applies rewrite rules, abstraction rules, to discard the non-existent part, or thought that the non-existent part is a parameter of the request object. As a result, the server sends back a success response, but actually includes the content of account.php, which contains private information, sensitive information about the victim's account. Unaware of the URL mapping that happened at the server side, the web cache store stores the response as a static email files because web caches based on the caching role cache the content based on the extension, which is JPG, obviously. And finally, in the final step, the attacker visits the same URL, which results in a cache hit and grant him unauthorized access to the victim's cache content information, most probably included private information or account information. In this presentation, as we explained, web cache technologies may be configured to make their caching decision based on complex roles, such as pattern matches of file names, extension, paths, and header content. Launching a successful web cache deception attack requires an attacker to craft a malicious URL that triggering a caching rules, but also on that it's interpreted as a legitimate request by the web server and generate a 200 OK or something like this and return a successful response. Caching rules often cannot be reliably predicted from an attacker external perspective, rendering the process of crafting an attack URL educated guesswork. But attacker always has an upper hand to predict this caching rule and create effective and novel attack scenario. The hypothesis that exploring variation on the path confusion techniques may increase the likelihood of triggering caching rules and a valid web server response, and make it possible to exploit additional web cache deception vulnerabilities on sites that are not impacted by original and traditional proposed attack techniques. To test our hypothesis, we perform a scale analysis and measurements on different websites and apply these path confusion techniques. We are going actually to share about these path confusion techniques, the effectiveness of this, and at the end, we are going actually to share our observations during the exploitation of the web cache deception in the wild.
So basically, encoding is at the core of our advanced exploitation techniques. So before we get to the actual techniques, the details of them, I'm going to go quickly over the URL encoding. So basically, the URL encoding is a technique to embed special or non-ASCII characters in the URL. There are a couple of special characters, such as semicolon, question mark, that have a special meaning in the URL. And in order to put them into the URL as a data, you need to encode them. And usually the encoding happens using a percentage followed by the hexadecimal representation of the ASCII code of that character. So, however, this encoding can bring more confusion between different components of the internet, such as the browsers and CDNs and the servers, if we apply custom encoding. And that's something we're going to explore through the future slides to tell you how different encoding can make the different components to have different interpretation of those encodings.
One of the effective techniques that we want to introduce in this presentation is using %3f or encoded question mark. These techniques target proxies, load balancer, any man-in-the-middle HTTP component with caching rules that are not configured to decode and ignore a standard URL query string that begin with a question mark. As JJ said, the traditional exploitations only add one slash at the end of the files and makes a confusion for the caching proxy, but this might target actually a different caching proxies that are not configured to decode the URL string, and will accept that %3f as part of the files. And most probably in case of the caching proxies or CDN, now the file is account.php %3f whole of the string. But in reality, because path confusion happened, account.php only considered as a file inside of the web server, and the path is a slash. This confusion might actually cause storing triggering the cache rules by saving the response of the account.php based on the extension, which is CSS. Same technique actually, as a second technique of the confusion that we want to introduce here is a %0a. Web servers proxies often, but not always, stop parsing URLs at a new line characters, discard the rest of the URL. As a result, a request for this URL would result in a successful response because the web server thought that it's account.php based on the rewrite rule, and the cache would store the content believing that this is a static content based on the non-existent file extension, same as the previous confusion technique.
So basically, there are some application servers that accept lists of parameters in the URL separated by a semicolon instead of using the query strings. And interestingly, when we encode those semicolons, the middle proxy and the CDNs, they don't necessarily decode the URL, and they don't understand that this is the semicolon. As a result, as you can see, if we append a non-existent CSS at the end of the URL and encode the semicolon, to the eyes of the web server, this is not more than something, a parameter, but to the eyes of the middle proxies and the CDNs, this be identified as a CSS file, and it's a good candidate for caching, which result in the content of the response, which contains private information, to be cached here. And last but not least is the fragment. So basically, the web servers often process the pound character as an HTML fragment identifier, and they stop parsing the URL when they reach this character. But the proxies and the caching servers don't necessarily decode the URL. They don't understand that this is the pound, and they continue parsing the URL. As a result, when we add a non-existent .css at the end of the account.php and separate them by the encoded version of the pound, the CDN thinks this is a CSS file and they want to cache it, even though the web server understands this is a fragment. It's going to throw it away and return a valid result.
Okay, let's talk about the effectiveness of presented confusion techniques and encoding. We did a scale analysis, analyzed lots of domains and sites, and we found 37 vulnerable sites with web cache deceptions. 25 were exploited by basic and traditional web cache deception technique exploitation techniques, but interestingly, we discovered 11 sites were exploited only by advanced and confusion techniques with web cache deception. It means we discovered an increased number of vulnerable sites by 45% by applying these 4 encoding techniques. More interestingly, we discovered some sites and a couple of domains that only exploited with one of the techniques. It means URL encoding is quite effective to confuse different CDNs and cache proxies. And attackers should design the attack scenario based on each target. An attacker always has an upper hand to find the effective path confusion techniques. I want to emphasize on this point that path confusion is not limited to actually these 4 techniques. Attackers, bug hunters, and even different administrators might be more creative to use different techniques, different encoding techniques, even double encodings or other characters to target the attacks and find the vulnerabilities. All in all, the results we presented in this slide confirm our hypothesis that launching web cache deception attack with variation on path confusion, as opposed to only using the originally proposed path parameter techniques, result in an increased possibility of successful exploitation significantly. Moreover, 2 of the explored variation elicit significantly more 200 server response in the process, increasing the likelihood of web server returning valid and private information. It means path confusion increased the chance of obtaining more sensitive information because forced the web servers to return 200 compared to the traditional techniques. Beside the scale analysis, we discovered lots of different enabling factors beside the web cache deception exploitations. And in this part of the presentation, we are going to share about the notable observation we had during the scale analysis of the web cache deception. Beside the effectiveness of the path confusion, we noticed that web cache deception are mostly known as is mostly known as techniques that can disclose sensitive information and PII. But web cache deception can be even more severe vulnerability and more critical vulnerability, because besides that finding a leakage of different PIIs, username, email, phone, and etc., we discovered in the cache pages, in, for example, some domains, we discovered CSRF token leaked in a web cache deception response attack. Consequently, we were able at the times to bypass the CSRF protection, which is only based on the CSRF token without presence of, for example, same site cookie or refer check. Also, we discovered some other use of the CSRF token as a state parameter in an OAuth protocol, which gave us this capability to us to run an OAuth redirection URL CSRF, consequently link an attacker's accounts to the victims. Or also we discovered session identifier, OAuth bird token, or API token, means session hijacking is still an effective attack scenario with combination of the web cache deception. Then web cache deception also might be used even to disclose some private file names, like as dynamic JavaScript file names, open the doors for cross-site scripting inclusion.
So basically, the victims have to be authenticated to the website in order for the website to generate responses with private information. However, we wanted to see how the situation should be for the attacker, whether it should be authenticated or unauthenticated. Interestingly, we figured out the attackers do not need to be authenticated in order to launch the web cache deception, which increase the likelihood of the WCD attacks, and even the website with no public registration can be targeted by the attackers. So one more thing we wanted to look into was the locality of the web cache deception. So basically, we wanted to see how much the attacker, how close the attacker should be to the victim in order to web cache deception to be possible. As you know, the caching, the basic concept of the caching is to bring the content closer to the user. As a result, we connected to a web cache server, which is close to a user from Boston, United States. And as an attacker, we try to load that content in Italy, the city of Trento. And interestingly, we saw that there were 6 websites that we were able to get the content of the cached resource that was written by the victim, which shows that the attack can be possible even cross-continent.
Okay. Another notable observation that we had is that web caches typically store objects for a short amount of time. It means attackers have a limit window of opportunity to launch a successful web cache deception attack. When we launch our attack during the vulnerable target, we noticed that repeated the attack with 1 hour, 6 hours, and 1 day delay for 19 websites that we studied. Only 16, 10, and 9 were exploitable in each case respectively. It clearly means, even we noticed that some websites is exploitable only for a couple of minutes, a few minutes. Then during the web cache deception vulnerability assessment, the security expert and bug hunter should make sure that they have a limited window of the time. It's highly dependent on the configuration of the cache server or CDN, but it's a very important topic that the attackers have a limited window of time.
We also tested top vendors that provide CDNs and wanted to see how their default configuration is. We've seen that by default, some major CDN vendors do not make RFC compliant caching decisions. For example, in Akamai, you basically can ignore all the headers and write down some specific rules based on the file extensions to cache your results, which shows that it could be very, very complicated the way different caching servers or different CDNs are handling the responses regarding the caching decisions.
Yeah, as JJ said, some major CDN vendors do not make RFC compliant caching decisions, or even if they are RFC compliant, they give this capability to administrator to ignore and override caching header, which makes web cache deception live and still an important attack scenario in the web. One of the important things that I want to conclude here, the lesson and learn of to conclude the presentation, is that configuring web caches, as JJ said, currently is not a trivial task. It's pretty complicated, and CDN are not designed to be a plug-and-play solutions. There is no widespread lack of user awareness about the web cache deception. As you can see, 3 years after publishing these attacks, there are lots of vulnerable websites in the wilds, high-profile websites, that even in our study, we detect them as a vulnerable, and we report to them this vulnerability. But still, we believe web cache deception is a system safety problems. In an environment with web cache deception vulnerabilities, there are no isolated faulty components. To be honest, web server, load balancer, proxies, and caches all individually perform the functionality they are designed for. Caching based on extension, overriding the cache headers, or even, for example, applying the abstraction layer of the URL representation as a clean URL. But security researchers should adopt a security analysis, examine not only individual system components, but also their interactions as a whole system. Most important things in this presentation, variation and path confusion techniques make it possible to exploit sites that are otherwise not impacted by original attack. Some sites were only exploitable with one specific encoding techniques, and encoding techniques can be designed specifically to hit 1 or 2 targets. And at the end, path confusion can be used in other attack vectors. In 2018, we showed that relative path override, RPO, can also Path confusion can apply in these attack techniques and increase the chance of the exploitability. Path confusion can apply to cache poisoning or CPDOS and other attacks. Special thanks for joining us in these presentations, and we will be happy to answer your question.
Thank you for attending our talk. I hope it was interesting and happy to answer your questions.